So in the previous videos, we discussed about the covariance and the correlation. So this correlation and the covariance will explain the relationship between the data. So by using that, the correlation and covariance that is used in statistics, that is used to predict the data. So we can use this to predict, to build a predictive model. For example, what is predictive model is if I has all this information, can I guess the average price? So by using the whatever data you have, you can build a predictive model of this data. By using first for that, in order to build a predictive model, I have to analyze the data first. When this data is fulfill some condition, then only I can use this to predict the data. So for building predictive model, we need to do some modeling techniques like regression modeling. So if your data is fulfill some condition, then you can say that is a good predictive model. So in this video, let's see how to build a predictive model. So in order to build a predictive model, we will use that regression. Okay. In this example, I have the data set with crime rate, age, index. This is the data set about a house. What's the real estate data set? It's about a housing. Here I have the crime rate, age of the house, index, NOx, number of nitric oxide, and industrial area, and distance, tax rate, pupil teacher ratio, average room of the house, lower status area, average price. So first I need to understand, in order to predict the average price, can I use this data? If I have this data, can I predict the average price? So in order to build the predictive model, you have to do first regression analysis. The condition of a good predictive model is satisfied with your data, then you can definitely do the predictive model based on this. So how to do it? First, go to data tab. Here you have data analysis. There you will get the regression. There search for the regression analysis. Here I have regression. I click on that. I said okay. I need to give the two inputs like y and x. So I will explain. The y is the independent variable which we are doing the prediction. Here all the other data is dependent. Average price is all the other data is independent. Average price is dependent because average price is influenced by all the other data. For example, average price of the house is depend on how much room it has, what's the distance from the city, what's the age of the house, like that. So this is the independent factor. These all others are the dependent factor. So the input range is the dependent factor. In this example, average price is the dependent variable. So I will select the average price. Then it will ask for the x variables. X variables means all the independent variables. I will select crime rate to till low status LST80, control shift time, select all the cells. So my dependent and the independent variables are selected. I will select the yes, I have the label in the first row. Then you want the residuals. I will explain what is that. Yeah. Then I hit OK. So it will give the regression table. So the first thing, if your model is good or not, whether it is good for predictive or not, the first thing you have to understand that the predictive model, whatever the R square you get it over here, it should be more than 62 percentage. Okay, it should be more than 62 percentage, and the adjusted R square, it should between the adjusted R square means the R square it minimized. negate some insignificant factor from that, and it will give the adjusted R square. This should be between the 1% variation. If your R square is 69 but your adjusted R square is 59, no, it will have 10% difference. No, it can't be accepted as a good model. You should have between 1%. Here I have 69 and here I have 68. So it is satisfied the first condition. So first you have to look on that the R square value. It should be more than 62%. Then in order to understand the significance of your what variables, this table gives that information how your variables are significant or insignificant to determine the independent variable. So it will give all the table like crime rate, age, average price, all that information, average room, all that information. It's give with the coefficient of that p-value. So the p-value is very important in order to decide whether that variable are significant or not. First you have to look on the p-value of the every variable. So the rules or condition for p-value for an best significant factor is that it should be below 5%, means it should below 0.05. It should below that. Above that it is considered as insignificant. You have to ignore that in our model. So just look at here. We have the p-value. Just don't look at for intercept. I will explain what is that. Look at for the column heading. Here for crime rate I have 53. 0.53 means 53% of p-value. So this is not fulfill my condition of p-value. It should be less than 5%. So here for age it is 0.012 means 1%. For index it is 0.3. 0.03. Yes, it is lesser than 5%. For NOx it is also less than 5%. For distance it's also less than 5%. All other here 6 point, but you have E means it is 0.0000015. After that 6 like that. This all others have less than 5%. So what I will do is I will ignore the next time when you have to do the regression model again, because you have one insignificant factor. You have to ignore that and again build the regression model. So I will ignore this one. Okay. So go to that table again. Then you have what crime rate as insignificant. I will select that and I delete that. Now I again do the data regression. Okay. First select the x range means dependent variable, then select independent variable. Okay, I have the label, all this condition. Then I hit OK. So again look for that. Yes, 69, more than 62%. Yes, the p-value, all the variables are less than 5%. So no need to delete any of the variables. So now the two condition is fulfilled. One is more than 62%, and the p-value of all the variables should be less than 5%. So these are the two conditions of a good model. Then you have to look for another. You will have the residual. Residual means actual value minus the predicted value. You will get the residual. So in order to call any model as a good model, its RMSE should be, it have some condition about RMSE. Okay, I will explain what is RMSE. To get RMSE, you have to first get the square of this residual. So how to get square? Equal sign, select this, and cap 2. You will get the square. Then I double click over here, it will get the square for whole and take the mean of that. Okay, to get the mean means average, and I select whole range. I got the mean. First I did the square, then get the mean. I want to get square root of. When I get square root, it is called as RMSC, means square root. The function called square root sqrt. I will select this. Okay, yes, I got the square. So this is RMSE. RMSE means error, means residual sum mean root, means first I did the square, then I sum it, take the mean, then I take the square root. You will get RMSE. So the condition for RMSE is RMSE should be 10% of the actual error. So how to find the actual error? Actual error, why actual? So actual error is nothing but the average of the dependent factor for which we are predicting average price, right? So first get the average of the average price. So average of this. So this is the average. This itself is a y actual, means maximum error can call. Then yeah, so the condition is this should be 10% of this. Okay, just check whether that is 10% of that or not. Just is equal to sign this divided by this. I hit enter. No, it is 22%. The RMSE is 22% of the actual error. So it didn't fulfill our condition. So we can't use this model as a predictive model. So there may be many reasons for this bug, because there may be outliers. So I will not dive on that topic of outlier. You can delete that outlier and you will get the perfect model. So this video is just understand how to build it, the regression model or predictive model. So condition that first it should be the R square should be more than 62%. The p-value of all the variables should be less than 5%, and the RMSC should be 10%, within the 10% of the actual maximum error. The actual error means average of the dependent factor. Then you have some condition to be fulfilled about the residual. The mean of the residual should be 0. Just check the residual you have here. The mean should be 0. First, mean of the residual means average. Okay. Then I select whole, enter. So that is minus 1 point till here E14, means it's close to 0. We can call it this is 0. Then the skewness, it should be normally distributed. Normally distributed in the sense it should normally distributed. There's there are no outlier and all this thing. So how to know whether that is normally distributed or not? That's why we use skewness. Okay, we have to check for skewness. Normal distributed, it will give the 0 value if that is normally distributed. If the skewness is more than 50%, means 0.50, it's known as right skew. If it is less than 0, the minus value, that is left skewed. So let's find the skewness of this. Sorry. Skewness is equal to skew. Then I select the number here, residual. Then I close bracket, enter. It is right skewed, so it is not normally distributed. And the next condition is the variance between the predicted value and the residual should be constant. Means the distribution should be constant between the predicted and the residual. So how we can get the whether the variance are constant, the relationship between the predicted value and the residual? So we will use scatter plot over here. So go to first select this, go to insert tab. You will have the scatter plot over here. Here you don't understand by looking at the number, but you can add the trend line to it. Yes, it is normally distributed because you will get a straight line over here. There is no relationship. Constant variance means there should be no relationship between the predicted value and the residual. So we will come to know about that by using the scatter plot. If the scatter plot showing any direction, means upper direction, lower direction, that means it have the relationship. If there is no relationship, it will represented by the straight line. So in this data, that represented the straight line. So there is a no relationship. So just understand this much. So in order to call any predictive model is the best, it should fulfill some condition. First one is the R square should be greater than 62%. The p-value of all the variables should be less than 5%, and the RMSE value should be 5% or 10% of the y actual, and about the residual of that model should be the mean is equal to 0, the skewness is 0, means normally distributed, and there should be no relationship between the predicted value and the residual. That we will know by using the scatter plot. If the scatter plot show any direction, that means that have the relationship. If any of this condition not met, you can't use that model as the perfect model, and you can't use that model to predict any variables. So you can make changes by negate the outliers. When you go deep into this topic, you will understand what is outliers, how to remove it, and what data is not important. So by deleting all that data, you can build a regression model, a predictive model. So if that all condition fulfilled, then you can use it as a predictive model. I already explained that why that model is important. So if for a business, the predictive model is best. You selected a predictive model and that met all the condition, then you can call it as a good predictive model. So you can give that to the business to predict its value. For example, you will find some of these factors are the independent factors will determine the average price. Then if you have any of the information, you can predict the average price. So it will help for the business to predict the average price. In this example, the average price of the house. If the company has some information about the distance or the index age of the house, by using this data, it can easily fix the price for that house. So this is the use of the predictive model. So in this video, we learned about how to build a predictive model, how to check the condition for the predictive model, how to check for it, and if that met, you can select it as a good predictive model. So this is about the regression modeling. Thank you for watching. Thank you.